So we're back with a couple more log questions. In this case, we're going to use logarithms to solve exponential equations. Well, just like everything else, what I do to one side, I can do to the other. So, I want to solve for x. It's the exponent. So how can I get rid of it as an exponent? I have this. I can't make them the same base like we've been doing, so what I'm going to do is I'm going to take the log of both sides. I'm going to make use of the law of the power, which means I have x times log 2 equals log 7. Now, just like everything else, dead mass, divide this side by log 2, which means I divide this side by log 2. So x equals log 7 divided by log 2. Now, I can't apply that other law that we were looking at, so I plug that in the calculator, and I get approximately 2.81. So x is approximately 2.81. That's the same way with every one of these. When I have an exponent and I can't change it to the same base, I use logs to solve. On that note, sometimes people will change this and use different bases. Currently, everything we're doing right now, we're assuming this number here is 10. So, if you were to plug it in your calculator, log 100, for example, means what number, 10 to the power of what, will give me 100. So what this is 2, because we assume there's a 10 here. 10 squared equals 100. So if I have a different situation and I had 2 to the power x equals 32, we know we can change this to 2 to the power of 5, but we can also write this as log base 2 for 32 is x. So this works the same as this, which is base 10, and it allows me to solve. So in the calculator, this is an option to use on TI-84. It is an option on the TI-84 under math. It allows you to work with logs of different bases than 10. But the same way as we were doing the question before, I can also go log 32 divided by log 5. Log 2 will give me 5. So x would equal 5. I can do that in the calculator as well. This is much easier if you don't like messing around with the different buttons. How did I get there? My base, my exponent, my argument. They always go together. So if I have 2 to the power of x equals 32, it changes, that comes here, that goes there, and that becomes the base. Another example. I can make use of the laws to solve these, the easier ones, as opposed to going to the calculator. So if I have 3 to the power of what equals 1 over 9. If I want to use logs to solve this, this would become log 3 1 over 9 equals x. Not very helpful, but log 3, this is 3 to the negative 2, based on my understanding of laws of exponents, I can change 1 over 9 to 3 to the negative 2 is x. So negative 2 log 3 equals x. Anytime I have the same base, and this, anytime the argument equals the base, this is 1. So I have negative 2 times 1 equals x. Negative 2 is x. And that's another easy way to solve, or you could go back to the other way and do it without logs. Without using a calculator, we'll do one more. I have log 381. What would my answer be? Well, I could just put it in the calculator way. Log 81 divided by log 3. And that'll give me 4. Or I can go log 3 to the power of 4 when my base is 3. So that becomes my answer. 3 to the power of 4. So log 381 is 4, because 3 to the power of 4 equals 81. Now, those are not the greatest. I hope there's a bit of understanding from what we just did. Check the textbook, come back, ask me questions. Hopefully we can get them all figured out.